Let's begin first with how to multiply fractions. We're going to learn and practice this by using recipes. Okay, our first recipe is one for making a drink. The recipe is enough for 2 people, but we are only going to make enough for 1 person, so we need to half the ingredients listed. The ingredients say that we require 2/3 of a bottle of apple juice, so we need to find how much we need for 1 person. To do this, we're going to multiply our 2/3 by 1/2. Multiplying fractions is really straightforward. You multiply your top numbers together and your bottom numbers together. The top number is called a numerator and the bottom number is called a denominator. So to our scenario, 2/3 multiplied by 1/2. 2 times 1 is 2 and 3 times 2 is 6. So we have 2/6. And then we check if it can simplify, and it can. And this simplifies to 1/3 because the largest number you can divide 2 and 6 by is 2. So 2 is the highest common factor of 2 and 6, leaving us with 1/3. The next item in our recipe is 2½ strawberries. Now we have a mixed fraction. To multiply this, first we have to convert it to an improper fraction. And this is done by multiplying our whole number by our denominator and adding it to our numerator. So 2 times 2 is 4, 4 plus 1 is 5. So 2½ as an improper fraction is 5/2, and now we can proceed just like we did in our first question. 5 times 1 is 5, 2 times 2 is 4, giving us 5/4 as our answer, and we check to see if it can simplify, and you'll find that it can't. So 2½ multiplied by 1/2 is 5/4. Alright, let's try some slightly harder examples. What is 3 2/3 multiplied by 1/6? So just like before, we need to convert our fraction. 3 times 3 is 9, plus the 2, that's 11. So our improper fraction is now 11/3. Now just like before, we multiply our numerators and we multiply our denominators. So 11/3 multiplied by 1/6 gives us 11/18, and that does not simplify any further. What if we're given a horrible looking question and we need to multiply 2 mixed fractions? So 2 2/5 multiplied by 3 1/3. We just follow the same patterns that we've already been practicing, and first we convert our fractions. We need to multiply our first denominator by 2. So 2 times 5, giving us 10. Add that to our numerator, leaving us with 12. So 2 2/5 as an improper fraction is 12/5. We do the same for our second fraction. 3 times 3 is 9, plus the 1 is 10. So 10/3. Now again, we do our last 2 steps. Multiply our numerators and denominators and check to see if it will simplify. So 12 times 10 is 120. 5 times 3 is 15. This gives us 120/15, and now we have to check for our highest common factors. Now 120 and 15 both have a factor of 15. 120 divided by 15 is 8, and that gives us our answer because 8/1 is equal to 8. So now you can multiply any types of fractions together. I included some conversion examples here, and if you need some more help or practice on that, or to refresh on it, then I will leave a link in the description for a video on that for you. Now let's look at the method for dividing fractions. What's really nice is that it's as easy as multiplication, but you have one extra step. So what is this one extra step? It is the flip. So the fraction that we're dividing by, we're going to flip it upside down. So if you had 2/3, that would become 3/2. If you had 1/5, that would become 5/1. So let's apply this to our question, and we have 2/3 now multiplied by 6/1. So 2 times 6 is 12. 3 times 1 is 3. And then you check to see if you can simplify, and it can simplify. 12 divided by 3 gives us exactly 4, and that is our answer. Let's try dividing mixed fractions. 2 1/3 divided by 3/5. Let's start by converting our mixed fraction. 2 times 3 is 6. and 6 plus 1 is 7, giving us 7 over 3. Let's do our flip, changing 3 over 5 to 5 over 3, leaving us with the problem to solve, 7 over 3 multiplied by 5 over 3. 7 times 5, 35. 3 times 3 is 9. So 35 over 9, and we check to see if this improper fraction could be simplified, and it can. 9 goes into 35 3 times, so 9, 18, 27, and there's 8 remaining. So 8 now becomes our numerator, and 9 remains our denominator. So now we can multiply any types of fractions, and we can divide any types of fractions. And before we move on to addition and subtraction, this flip that we're doing, the number that you're producing is called the reciprocal. So in one of our examples, we flipped 1/6 to become 6 over 1. 6 over 1 is the reciprocal of 1 over 6. Essentially what that means is the number that you multiply your fraction by to give you the value of 1. So if you come across examples like this and they're asking for reciprocals or talking about them, that's what it is. It's the flipped version of the fraction. So addition and subtraction. I'm going to be mainly sticking with addition, but the same rules apply to subtraction. And just like before, there's patterns to look out for or tricks to look out for. So what do we have to look out for in addition and subtraction questions? We just have to check if our denominators match. And if they do, it's very easy. If we're being told to add, we just add our numerators. And if we're being told to subtract, we just subtract our numerators. Let's look at our first problem. In this recipe, we need 1/4 of a tablespoon of pepper, but instead of making this for one person, let's make it to 2. So 1/4 plus 1/4 is the problem that we need to solve. We check and our denominators do match, so we can simply add our numerators. And this gives us 2/4. We have to do our last step, which is simplify, and that leaves us with 1/2. 2 1/10 plus 3 over 10. So we convert our fraction. 2 times 10 equals 20. 20 plus 1 equals 21, so 21 over 10. Now that our denominators match, we can add like before. So 21 plus 3 over 10 equals 24 over 10. And this can simplify because we can divide both our top and bottom by 2. So 12 over 5. For our final example, let's try the addition of two mixed fractions. 3 2/5 plus 2 1/5. We convert our mixed fractions as before, leaving us with 17 over 5 and 11 over 5. So 11 plus 17, giving us 28, 28 over 5. And then we check and see if we can leave this as a mixed fraction. 28 divided by 5 is 5, with a remainder of 3, as 5 times 5 is 25, with 3 left. So as a mixed fraction, 28/5 is 5 3/5. Okay, finally, let's look at what we do for addition and subtraction when our denominators don't match. To make this noodle dish, we are going to combine two of our favorite recipes. So 1/2 plus 1/3. Now our denominators don't match, so what do? One extra step, we force them to match. We find a common multiple of 2 and 3, so a number that both 2 and 3 can become when you multiply them. 2 and 3 are both capable of becoming 6. So for our first fraction, 1/2, if we multiply the top and bottom by 2, because whatever we do to the bottom, we must also do to the top. So 2 times 3 equals 6, and 2 times 1 equals 2. And then for our second fraction, if we multiply the top and the bottom by 3, that will also make our denominator become 6. So now we are left with the problem of 2 over 6 plus 3 over 6, and we can proceed as normal as we've made our denominators match. If this was subtraction, we would subtract them. The same rules apply to subtraction and addition. 3 plus 2 equals 5, so our answer is 5/6. It doesn't simplify any further. Okay, so what if we have a problem that features two mixed fractions and the denominators are not the same? First, we convert our mixed fractions to improper fractions. 2 times 3 equals 6 plus 1 equals 7, so 7/3. 2 times 4 equals 8, 8 plus 1, 9, so 9/4. Now we need to do our extra step because our denominators don't match. We need to force them to match. The lowest common multiple of 3 and 4 is 12, so 4 times 3 equals 12, and we have to do the same to our numerator. 7 times 4 equals 28, giving us our first fraction, 28/12. 4 times 3 equals 12, and 9 times 3 equals 27, and we now have our second fraction. Also, we have forced our denominators to match. So we finish up by adding our numerators. 28 plus 27, that equals 55. So our answer is 55/12, which again, if you want to convert this to a mixed fraction, leaves you with 4 and 7/12. So, as a final recap, to multiply fractions, we just multiply our numerators and denominators and check and see if our answer can simplify. To divide fractions, we get our reciprocal, which we do by performing our flip, and then we do exactly the same as multiplication, and we treat it as a multiplication question. For addition and subtraction, you check to see if your denominators match. If they do, you simply add or subtract your numerators, and if they don't match, then you force them to match, and then add or subtract your numerators.